Alright, hello class. Today we're going to be going over lesson 5, which is on basic equations. I still kind of consider this review material, mainly because these are equations of the type that I think you all are very familiar with by this point, hopefully. Specifically, we're going to be looking at linear equations, or things that end up being linear equations. And I'll go over what I mean by that in just a moment. But these are the types where you have basically your 3 steps. You simplify both sides, and this should be your first step. No matter what equation you're trying to solve, a lot of times you can get what you're looking for just by simplifying everything you see. Step 2 is you move x's to one side, and everything else to the other, all your constants to the other side. Okay. Then of course you're going to multiply or divide to get x all by itself, and that's it. Okay. So I don't think this one will be a very long lecture, actually. We'll look at some examples, but this is your standard equation type, right? Get all your x's on one side, get everything else on the other, and divide or multiply to get x isolated all by itself. Once you do that, you have x equals some number, and that's your answer. Okay, there's some subtleties there that we'll talk about. Okay, but let's look at some examples. Alright, so the type of equations I'm talking about, of course, are something like this. We want to solve 2x minus 2 is equal to 12. Right, and I'm hoping you all have seen this thousands of times before. First, we're going to move x's to one side, everything else to the other. So we only have the 1x over here, so we'll leave that, but we'll move this negative 2 over, and to do so we add 2 to both sides, which will cancel. I see some people mess this up and try and subtract 2. Remember, the operation you get is supposed to get you 0. That's how you're moving things, is you're doing the opposite operation to cancel those out and get a 0, so that on this side of the equation you're left with just 2x and is equal to 14. Okay. Now that we've done that first step, we're just going to divide by 2, since that's the number in front of x, to isolate x. Okay, so we'll get x is equal to 14 divided by 2, which is 7. Now, the one thing I want to talk about here, and this is one of the subtleties, is when you're doing your homework, the problem sets are going to give you a choice. The first option says the solution set is, and it will have brackets and a little blank space for you to put something in. The next option is the solution set and it gives you this weird looking set here. It gives you a curly brace, an x, a bar, and then it says x is a real number. Okay, and then the third option is the solution set is phi. That's a Greek letter, phi. What do these things mean? Well, if you have a solution, like we do here, our answer is 7. Okay, we're just going to choose this first one. The solution set is this. You're going to see this throughout the semester. In these brackets here, it just wants you to list all the answers that you got, all the things x can be. Okay. this second option here is the solution set is basically saying it's all x such that x is a real number. What this means is if we ever have a situation where the equation is true for every single x, this is called an identity sometimes, or a tautology, just meaning it's true for all x. And I'll do an example next that kind of shows this property off. And then this, the solution set, is this phi. This is the empty set. In other words, this is another way of writing the set of equation or solutions with nothing in it, right? You just put a blank. Instead, we just write this because this is a little, maybe a little misleading sometimes. What this means is that no x's work. Okay? There's no solution. Okay, and I'll do an example of one of those in a second as well. Okay, but typically these are the three options you're going to use. And if you get a number out, you're just going to put it in your braces there. Alright, for our second example, let's look at the equation 10x plus 20 is equal to 5, all times 2x plus 4. Okay, so this is going to lead us into the whole simplify both sides thing. Alright? So, let's see. On this side of the equation, there's not really much we can do to simplify. Okay, but over here, what we can do is distribute that 5. Right, so if we distribute this 5 on this side of the equation, we're going to get 5 times the 2x, which is 10x. And then we're going to get 5 times the 4, which is 20. Okay. Now, some of you might see here that we have the same thing on both sides of the equation. This is actually going to lead us to that second option where no matter what x we choose, we're going to get the right answer. But let me show you what happens if we try to solve this normally. Remember, what we want to do is move the x's to one side, everything else to the other. So if I start with my x's, and let's say I want to move this negative 10x over to here, it actually cancels on both sides. So then what happens is we end up with the equation 20 is equal to 20. Now, this is always true, right? Hopefully you all agree with that. If you ever get down to something like this, that 20 is equal to 20, or 0 is equal to 0, or 5 is equal to 5, your answer is really all x's are going to work. Because the x's disappear and then you get an actual equation that is true. Okay, so the solution set, we would say, is that funky one, all x such that x is a real number. Okay, and that's that. So if you ever end up getting down to an equation that is just always true, 20 is equal to 20, 5 is equal to 5, 0 is equal to 0, you have pretty much all real numbers is your solution. Everything is going to work for this equation. Alright, let's look at this next equation. This is also getting us into sort of the more complicated problems, but this is about as complicated as they get for linear equations. Basically, you have some stuff to simplify on each side, then you're going to move things around and you try to get x's on one side, everything else on the other. So for the left-hand side of the equation, to simplify this, we're going to start by distributing this 2. Okay. And to simplify on this side of the equation, we're going to distribute this 3. Okay. All right, so let's do that. That 11 will sit outside. That 2 will distribute, and the 2 times the 3x will give us a 6x, and the 2 times the negative 15 will give us a negative 30. Okay. Now on this side, when I distribute the 3, I'm going to get a 6x. And when I distribute the 3 to the negative 10, I'll get a negative 30. And then that plus 7 stays. Okay, some stuff to be on the lookout for here. Notice that we have the same exact stuff, right? We have a 6x minus 30 and a 6x minus 30. Whenever you have that, those things you can actually just cancel across, because once you start moving things, you know, they're going to cancel. But if you didn't see that, we could just go ahead and do this equation as we normally would. For example, on this side, if I combine my like terms, that's the next way to simplify. And that's what I mean by completely simplifying each side. You distribute what you need to, and you combine like terms. So this 11 minus 30 is going to come out to be a negative 19. And this 6x minus 30 plus 7, that should give me a 6x minus 23. Okay, so we have this equation now. All right, and if, like last time, if I start by moving my x's which match, all right, let's say move this 6x over to here, what happens is those 6x's cancel, and then we get down to this equation here, that negative 19 is equal to negative 23. Oh, but that's not true. Right? Negative 19 is only equal to negative 19, and negative 23 is equal to negative 23. These two are not equal. Also, if you were to, say, move this negative 23 over to move that over, say if you just keep moving things, you're going to get that 4 is equal to 0. Also not true. Okay? There are a lot of ways to do this and get something that's not true. Like I said, we could, since these are the same on both sides, cancel them out and get an 11 is equal to 7. Okay? No matter how we shake it, really, we get stuff that makes no sense. We get garbage, right? Negative 19 is equal to negative 23. That's not true. In fact, that's silly. If someone told you that, you'd think they were crazy. Or if they at least told you that, said they believed it, you'd think they were crazy. This is the option for the solution set. Is the empty set, meaning there is no solution. All right. I want you all to be careful with this option. Also with the one we looked at before where all x's work. They don't come up as often as the others, right? You'll typically have a solution, but if not, that's what this option is about. That it's possible to set yourself up with no solution being your option. Okay, and it's usually pretty much always going to happen when things boil down to you basically have the same equation on both sides in some form, and then something that makes them different on both sides. Okay, let's look at another example. Alright, here we go. Here's an example of a linear equation. It's going to take a lot of simplifications and combining like terms and moving stuff around, and hopefully we'll actually get an answer out. Right, so let's start by distributing. Right, so I'll distribute this 2 across the x and the minus 3. I'll distribute this negative 3 across the x and the 2. Remember, you got to grab this sign as well. It's a common mistake. This x plus 2 could just stay as x plus 2, but we're also going to distribute this negative sign across there. Alright, so when we do this, distributing the 2, I'm going to get a 2x minus 6. When I distribute that negative 3, I'm going to get a minus 3x, then a plus 6. So remember, this negative 3 and the negative 2 will come together to give me a positive 6. So that's that on this side. Okay, on this side I have an x plus 2. That will stay the same, but then when I distribute this minus sign, I'm going to get a negative x plus 5. Alright, we actually have some things canceling. On this side, the negative 6 and the positive 6 cancel. And on this side, the x's cancel. Alright, so here the 2x minus 3x is going to give us negative x, and the 2 plus 5 is going to give us 7. In order to, we don't want to leave this as negative x equals something, we're going to divide both sides by negative 1. Okay, so 7 divided by negative 1 is going to be negative 7, and there's our solution. So here the option you would choose would be your solution set is negative 7. Alright, here's an example that takes some serious simplification. We got a big mess here. Alright, so first we're just going to try and simplify this the best we can. To start, remember what your order of operations says. Remember the first step of order of operations, parentheses or grouping symbols. Okay, so what that means is I'm going to work on the inside of these brackets here first and simplify that. All right. So before I start trying to distribute this negative sign or working in any of this stuff, I'm going to jump into this bigger, larger bracket and start simplifying that. So the first thing I see is to distribute that 2. Okay, so I'll leave the rest of this alone. You get a 4 plus 4x minus a 2x minus 6. Okay, and then over here, I could actually distribute this right now, since these are 2 separate pieces. Kind of like here, I didn't mess with the 25 because there's nothing to simplify. So we can actually distribute this negative 3 to get a negative 6x plus 12 here when we distribute that negative 3. Alright, I'm going to leave the negative out here with this bracket and simplify the inside of this grouping symbol thing. Okay, so when I can, I'm going to work inside out when it comes to things in parentheses and parentheses. So we're going to start by distributing this 2 to get a negative 2, or sorry, to get a 2x minus 2, then minus 15x plus 8 here. Okay, now I'm going to go through and within my parentheses or my brackets here combine like terms. I have a lot of like terms that we could combine here. So that 25 isn't going to change. I'm not going to distribute the negative yet. We could if we wanted to, but this 4 minus 6 will give me a negative 2, and this 4x minus 2x will give me a plus 2x. Okay. Over here, I'll leave this negative 6x plus 12 alone. Then over here, I'll leave the minus out front, and now I'll just combine like terms. This 2x minus 15x, that's going to give me a negative 13x, and then this minus 2 plus 8 will give me plus 6. Okay, As you can see, things look much, much better now compared to when they started. So when you see a big equation like this or big problem like this, my advice is don't just freak out because you see it's a big equation. Start tackling it a step at a time. What did I do? I started by going inside each of my parentheses and distributing. That's usually a good first thing to do. Then I went through and combined all my like terms that I could within the parentheses. Okay. Now I'm going to distribute this negative sign. Okay. So let's do that. Distributing the negative, the 25 still stays the same. We're now going to get a plus 2 minus 2x. Remember, it's a very common mistake to only apply the negative to the first thing. You need to distribute it. Okay? Even draw these arrows if you have to. Remember, the whole point of this is not to rush through the problems. It's to get them right. Actually, many, many years ago, I was hired to tutor a student who had failed. He was in high school, I think. He failed algebra. And when I started tutoring him, I realized that he actually knew how to do everything. His problem was he was rushing through every step, and he would make really silly mistakes and get every single answer wrong. All I did not teach him any math as a tutor. All I did was make him slow down for every step. And he went from an F to a B in a 6 weeks period. Okay? That can make a huge difference, more than you might think. So don't try and rush through all this stuff. If you need to write these arrows and all that just to make sure you're getting it correct, it's better to do that and take a little extra time than to just get it wrong. What is this saying? Haste makes waste? It applies here as well. So here we'll distribute this negative. You get a plus 13x minus 6. Okay. Now we have a bunch of like terms that we can combine. Alright, so let's do that. This 25 plus 2 is going to give me a 27 minus 2x. So there's this side with all of its terms combined. And then here, this minus 6x plus 13 will give me a 7x, and this 12 minus 6 will give me a 6. Okay? Alright, now we're dealing with a much nicer equation. A question I get asked often is, does it matter what side you move your x's to and what side you move your constants to? And in general, no, it doesn't. But how I usually do it, I usually move things so that I get rid of any negatives. So notice here, if I move the 7x to this side, I would be subtracting 7x on both sides, and I would be ending up with a negative here. Okay? What I'm going to do instead is move the 2x over, because I can add 2x to both sides, excuse me. Okay. And that gets rid of the negatives that I might introduce. So here I'll have a 27 is equal to a 9x plus 6. Okay, so now I have no negatives. And the same thing here. Now that I have the x's on one side, I'm going to move the 6 over to get my constants on the other. So that will cancel, and we'll get 21 is equal to 9x. Okay. All right. Now we're just going to divide both sides by 9 and get that over on this side. Remember, we can write this in any order we want. X is going to be 21 over 9. And it's okay to leave it as a fraction. The only thing we need to keep in mind here is we can actually simplify this. We can take a 3 out of both of these, right? 21 is 7 times 3, 9 is 3 times 3, so our 3's cancel, and we get 7/3. Okay? So no problem if you get a fraction. just simplify it down, and that'll be your answer. So when you do the solution set, it'll just be 7/3. All right, what happens if you have fractions in your equation? Okay, well, clearly you could just do all the fraction arithmetic that we have here, but let me show you a little trick. When you have denominators, and here they're all just constants, I have a 3, I have a 6, I have a 2, you can actually multiply the entire equation by a specific number that will cancel out all the denominators. So what we're going to do is multiply by a special number. Okay. What is that special number? Well, in this case, I'm going to try 6. Now, here's the thing. If you don't just automatically look at it and see what it's supposed to be, what you can always do is just take all the denominators and multiply them together and use that. Okay, you'll end up with larger numbers than you need, but the reason I'm going to choose 6 is because of this. 6 is 3 times 2, and my other denominators are 3 and 2. Okay, if you don't choose the right number first, say you choose one and it only cancels out half your denominators, just pick another number and multiply everything through. It'll work out. Okay, it'll work out. So we're going to multiply by, I probably shouldn't use an X here, use the dot. We're going to multiply by 6. Okay, so everything. So remember, with an equation, if you multiply one thing in the equation by something, you have to multiply everything by it. So I'm going to go through and multiply every piece of this equation by 6. So it's going to be 6 times 5x over 3 and minus 6 times x is equal to 6 times x over 6 minus 6 times 5 over 2. So we see here that I just took every single piece and multiplied it by 6, and I snuck it in between the sign as well. Right? You could write it on the other side if that helps. It doesn't really matter how you write it, but once we multiply everything by 6, all of our fractions start to cancel. Right? This 3 cancels with the 6 and leaves a 2. Okay. These 6's just straight up cancel, and this 2 cancels with the 6 and leaves a 3. Okay. And so then, let me rewrite this. This is 2 times 5x minus 6x, which is equal to, this just becomes an x, and then we have minus 3 times 5. Okay, I left it with the multiplication there to just show what happens with the same dots. Okay. And now, once we do this multiplication, what we'll see is we have 10x minus 6x is equal to x minus 15. We have just a normal equation now. I should say we have a normal equation now with no fractions. Okay, so multiplying by a special number to get rid of all your denominators gets rid of all your fractions. So up here, you could just do the fraction arithmetic in each case, get a common denominator, blah, 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 or, and what you probably noticed, or maybe if you haven't, but this is the pattern, this is the common denominator. All right, the common denominator you would choose here, you just multiply everything by it. And that's actually the nice thing about equations, is that you can do any operation you want as long as you do it to everything. Right? So we can actually multiply by these special numbers to cancel out all the denominators. All right, so now we just have a normal equation to solve. We'll combine our like terms here. So we'll get 10x minus 6x, which will be 4x, is equal to x minus 15. And now we'll move the x over. Notice I could have moved the 4x over and then the negative 15 over here, but that's way more movement than we need. If I move this x over, I'll get a 3x is equal to negative 15. So now I have everything I need. I have all my x's on one side, everything else on the other, and so we'll just divide both sides by 3. Okay, to get that x is equal to negative 5. Right, so when setting up your solution set, it will be just negative 5 in brackets. Okay, so that's how you deal with fractions. Although a natural question would be, how do you deal with fractions with x's in the denominator? Well, let me show you. All right, so here's an equation with fractions, but we have x's in the denominator. So remember, back to our rational expressions thing, that whenever you have x's in the denominator, you have to be very careful, okay? Because you're not allowed to divide by 0. So first thing I want to do is go through and just check to see where we might have division by 0. Okay, so basically if we put 0 in for x, we would get division by 0. So x equals 0 would cause division by 0. So x cannot equal 0, right? I'm putting that off to the side, because if we solve this equation and we get 0 as a solution, that is going to be one of our there is no solution things, because we'll end up with something that can't come to pass. We're not allowed to plug 0 in. Okay? Your MyLabs Plus questions will actually ask you about this. It will ask you about restrictions on the variable x. So this is the restriction on x. Okay? Restriction on x is that it's not allowed to be 0. All right. Now, we're going to approach this in the exact same way we did before. We're going to multiply by a special thing that will cancel out all of our denominators. So our two denominators are 5x and x. Okay? So multiplying by x will get rid of all of the x's. Multiplying by 5 will get rid of this 5. So we'll multiply by 5x. Okay? We don't want to just multiply them together this time, because doing that will be multiplying by 5x squared, and that will introduce more x's than we actually need. And then that will also, when we solve that equation, give us a solution of 0 more than likely. So we don't want to multiply by 5x squared if we can help it. Right, we just want to get the the common denominator. Okay, so in other words, this guy's almost 5x. These almost match, they're just missing a 5. You can also think about it as if I multiply everything by x, the x's will cancel. Then if I multiply everything by 5, the 5 will cancel. You can do it in steps like that. Say in the previous one, you could have multiplied everything by 2, then multiplied everything by 3, and then all your denominators would have been gone. Same thing here. We could start by just multiplying everything by x, and then everything by 5, and it will still work. I'm going to just do it in one step. All right, so I'll take this 7, or x minus 7 over 5x, and multiply it by 5x. Then I have the 1 times 5x. Remember, you have to multiply everything by 5x, everything. And then this will be x plus 3 over x times 5x. Okay, and then we just go through and cancel. So here, the 5x is canceled completely. Here, this will just end up being 5x. And then here, just the x is canceled. So we have to be careful here when we do this. Let me actually put these in parentheses. Okay, a lot of times I put my fraction pieces in parentheses just to be sure. So we multiply by the 5. Well, here everything canceled, so we just end up with a 7 or x minus 7. Then here the 1 times 5x will just be 5x. But then here, we're left with an x plus 3, and that whole thing times 5. Right, we have to distribute that 5 across that. It's not just multiplying by the 3. That 5 distributes. Okay? So that's one thing to be really careful about when you have sums with x's in it, that those things left over distribute. Okay, so we'll simplify what we have. I have a x and a 5x, so that will be a 6x minus 7. Then distributing the 5, I'll get a 5x plus 15. Okay. Now we're where we need to be. We're just going to start moving things around. Okay. Again, how you do it doesn't really matter that much. It will all come out in the wash. But I like to move things so that we rid ourselves of negatives. So I'm going to move the 5x over. And the reason I do that is because I know this 6x minus 5x will just give me x. At the same time, I'm going to move the 7 over. Okay. And we can do these in the same step. If you're not comfortable with that, that's okay. You could do it in separate steps. But here, we'll do it in a single step. So this 6x minus 5x will be x. The negative 7 plus 7 gives me 0. This 5x minus 5x gives me 0. And this 15 plus 7 gives me 22. And there we go. My solution set is 22. And this isn't 0. Right? It's not 0, so it's okay to actually put this in. Let's actually check our answer. We haven't done that before. This is one of those weird equations where you might not believe that this technique works. So let's plug 22 into here and see if we get the right thing out. All right? So to plug that in, I'll do it over here. Let's do 22 minus 7, all divided by 22 times 5, plus 1. And we're going to see if that's equal to 22 plus 3 all over 22. So all I've done here is replaced all my x's with 22, just to see if we get the right thing. Right? That's what we're trying to find. So 22 divided by, subtracted by 7 is 15, and 22 times 5 is 110. Okay, plus 1, and then 22 plus 3 is going to be 25 over 22. Okay, so the question here might be, this doesn't look like they're going to be anywhere close to being the same, but we'll probably get some cancellations here. We could pull a 5 out of this, 15, and get a 3, and we can pull a 5 out of this. We started with that, right? It was 22 times 5, so we'll get 22. So this is 3 over 22 plus 1 is equal, and we're actually checking that to see. We want to see if it's equal to 25 over 22. And this looks a little more likely, because 1, remember 1 you can rewrite as anything over itself. So what I'm going to do is say that 1 is 22 over 22. Okay, and now that we have common denominators, we could just add the tops. So 22 plus 3 is going to be 25 over 22. All right, so that method works. We got what we wanted. We got what made sense. Okay, so that was just to show you, if you want to check your work, you can always plug the solution you got back into the original equation, and it should come out in the wash and work out to give you something like this. Okay. All right, let's do another equation with x's in the denominators. Alright, so for our next example, let's look at 5 over x plus 5, 3 over x minus 2, and 21 over x squared plus 3x minus 10. Alright, so this one's a little more complicated. We have x's in the denominator, but it's not just x's. We have x plus 5, x minus 2, and x squared plus 3x minus 10. Okay, so we're going to start by finding any restrictions on the variable, or finding where the variable, or x, will cause division by 0. Okay, so to start, remember what our first thing to do is to divide, or not divide, but to factor this. Because if we factor this denominator, we'll see very quickly, hopefully, what x's are not allowed to equal. Okay, so let's factor this. I want factors of negative 10 that sum up to be 3. Okay. So negative 10. How about 5 and negative 2? Okay, 5 and negative 2 will multiply to give me negative 10, and they'll sum together to give me positive 3. So we'll get 5 over x plus 5, 3 over x minus 2, and 21 all over, when we factor this, x plus 5 times x minus 2. Alright, so this is starting to clear up a little bit. What we have here is really two denominator pieces, right? We have an x plus 5, we have an x minus 2, x plus 5, x minus 2. So this denominator is made up of these two. Okay? So, what makes these equal to 0? Well, if I plug in a negative 5, this denominator will be 0. If I plug in a positive 2, this denominator will be 0. And it will be true for this one too, because if I plug in a negative 5, that 0 times this will be 0. And if I plug in a 2, this times anything there will also be 0. So, sorry about that. So x cannot be negative 5 or positive 2. Right? There's the restriction on x. We're not allowed to let x be either of those things. Now, whenever we have x's in the denominator, or really any denominator that we don't like, we can multiply by something special to get rid of it. So, to do that, we're going to take these two pieces. So if I multiply by x plus 5, the x plus 5s will cancel here and here. If I multiply by an x minus 2, the x minus 2s will cancel here and here. So if I bring these two together, this x plus 5 and x minus 2, if I multiply my equation by this, all my denominators should cancel. So remember, to find all of this, we actually had to factor this. So if it doesn't come factored, well, factor it. Okay? Let's see if we can get this to focus. Okay. So, let's multiply everything by this. Alright, so I'm going to put things in parentheses, and we might need a bit of room, but I'm going to take 5 over x plus 5 and multiply it by an x plus 5 times an x minus 2. Okay, I'm going to take this 3 over x minus 2 and multiply it by an x plus 5 times an x minus 2. And then I'm going to say that's equal to, and I'm going to take this 21 over x plus 5 times x minus 2, goodness, and multiply the whole thing by x plus 5 times x minus 2, and I'm probably off the camera at this point. Yep. So, zoom out just a hair. Okay. Now, we're going to go through and just cancel everything like we did before. It's a little more complicated, but not by much. Just consider each of these like little separate blocks. And here, the x plus 5's cancel. And we're left with an x minus 2 and a 5. Okay. Here, the x minus 2's cancel. So x minus 2, x minus 2. And we're left with an x plus 5 and a 3. And then here, the x plus 5's and the x minus 2's both cancel, and we're left with just a 21. So the equation, when it's all said and done, simplifies down to 5 times x minus 2 plus 3 times x plus 5 is equal to 21. Okay. All right, so it looked like we had a step here that was just awful, but it simplified down to something very nice, relatively speaking, compared to all the other steps we have here. Our fractions are gone, and we just solve this like normal. I'm going to distribute the 5, and I'm going to distribute the 3. Okay, so we'll get 5x minus 10 plus 3x plus 15 is equal to 21. Okay. Now let's combine our like terms. I have a 5x and a 3x. That's going to give me an 8x. And then I have a negative 10 plus a 15. So that is going to give me plus 5. All right. So now I don't need to move the x's because they're all on one side already. I just need to move the 5. So that's going to give me a 16. Wait. Yeah, 16. Alright, so I'll do that over here. I'll have 8x is equal to 16. Okay, then we're going to divide both sides by 8 to finish off this equation. So we're going to get x is equal to 16 divided by 8, which is 2. Oh, but hang on. Hang on. What was x not allowed to equal? Oh, x is not allowed to equal negative 5 or 2. We got 2 as our solution. Well, that just means, sorry, no solution. All that work just to find that there's no solution, and the solution set is the empty set. Well, that happens sometimes. But you never know. We could have done all this work and actually gotten an answer that would work. But I wanted to show you all a situation where this would happen, where you'd get the one solution you found was not allowed. Right? It's one of your not allowed x's. Okay, that can happen. But in general, whenever you have fractions, multiply everything through so that you can cancel the denominators. And if there are x's in them, just be very careful that you omit the correct x values. Okay, and make sure that you're not saying your solution is one of them. All right, I think that should get you going on the homework for this section. The next section will be looking at various other types of equations. And I'll talk to you all then. Cheers.